Hey everyone, and welcome. Today we're going to tackle a question that sounds like it's straight out of science fiction. How does a computer actually understand what we mean? I'm not talking about just matching words, but really getting the feel, the context of an idea. It's a huge challenge, and the solutions are honestly incredible.
I mean, really think about that for a second. How do you tell a machine to find something based on a vibe? Like a melancholy rainy day song, or a photo that just feels adventurous. Seems impossible, right? You're not giving it a word, you're giving it a feeling. Well, that's exactly the puzzle we're going to piece together today.
And believe me, this isn't some far-off future tech, it's literally in your pocket. You know when you type dog into your phone's photo search, and it somehow finds every single picture of your pup, the blurry action shots, the sleepy ones, the ones from years ago you never even tagged? That right there, that's the magic. It's called semantic search, and it's all thanks to a totally new way of organizing information.
So, to really get this new magic, we have to look back at the old way. For the longest time, search was just about keywords. A traditional database was like a library's card catalog. Super literal. You ask for dog, you get results with the word dog. That's it. But a meaning search? That's totally different. It's like having this genius librarian who, when you ask about a dog, just knows you might also want to see stuff about puppies, or golden retrievers, or even canine companions. It just gets it.
So let's run with that analogy. Let's picture a brand new kind of library. We'll call it the conceptual library. Now, in this library, nothing is organized alphabetically. Instead, everything is arranged by its core ideas and themes. So all the books about heroism are in one area, whether it's a sci-fi novel, a historical biography, or a fantasy epic. This is exactly how modern AI databases, called vector databases, work.
Okay, so how in the world does this library actually get organized? Well, the secret sauce is something called vector embedding. Basically, an AI is trained on a massive amount of human knowledge, and it learns the relationships between, well, everything. It can then take any piece of data, a sentence, a photo of your dog, a song, and turn it into a long string of numbers. That list of numbers is called a vector, and it's like a super specific GPS coordinate in our conceptual library that pinpoints the item's true meaning.
Now here's where things get really crazy. This isn't your neighborhood library. We are talking about modern datasets with billions, with a B, of items. Spotify has tens of millions of songs. Google has billions and billions of images. Our conceptual library is, for all practical purposes, unimaginably huge.
And that leads us to the million-dollar question, right? If you ask our librarian for something specific, like a story about a brave hero fighting a dragon, how can they possibly find the perfect match in a library with a billion items without spending the next 50 years searching every single shelf? Just checking every single item, what we call a brute force search, is just not going to work. It's way too slow.
The solution is actually the same one real librarians figured out ages ago. You need a brilliant organizational system. In the world of AI, this is called indexing. And indexing is all about creating these clever maps and shortcuts that let our librarians zoom right into the correct neighborhood of the library almost instantly, skipping over hundreds of millions of things that aren't relevant.
So, how do we build these shortcuts? Well, the first major system is one we can think of as the genre sections. The technical name is IVF, or Inverted File Index, and it's probably the most intuitive way to do it. You just group similar things together into big categories, just like a real library does with sci-fi or history or mystery.
Let's quickly break down how this one works. So first, the AI looks at everything in the library and groups similar items into clusters. These are our genres. Then, anytime a new book or a new piece of data comes in, it automatically gets filed into the closest genre section. And finally, when you ask for something, the librarian doesn't waste time searching the whole library. They just go to the one or two sections that are most likely to have what you want. It's smart, simple, and pretty darn fast.
But what happens when genres are just too broad? Well, there's a more advanced system, one we can call the Web of Connections. Its technical name is HNSW. Now, instead of just putting books into general sections, this method builds this incredibly complex network that connects every single book to its closest neighbors.
So how does this amazing network get built? Well, first, every item gets a direct link to its most similar neighbors. Think of these as little local side streets. But here's the brilliant part. The system also builds out express lanes. These are like cross-library highways that connect distant but related parts of the library. So when you're looking for something, the librarian can just hop on a highway to get to the right general area in a flash, and then use those local side streets to find the perfect match. It is unbelievably fast.
But here's the thing.
Neither of these systems is absolutely perfect. And that's because they're based on this fundamental trade-off that exists everywhere in computer science. It's a choice between speed and 100% perfect accuracy. Do you want the absolute single best answer, even if it takes a little while to find? Or is a 99.9% perfect answer delivered in the blink of an eye good enough? For most things we do, the answer is a definite yes.
Okay, so let's put them side by side. The genre system, IVF, is quicker to build and doesn't take up as much memory. It's solid. But the web of connections, HNSW, is just ridiculously fast when you're searching, and it's usually more accurate. The catch? It takes a lot more time and memory to build that complex network of highways in the first place. So, picking the right one really just depends on what you need your AI to do.
So, why does any of this techie stuff matter to you? Well, because this is the engine that's running behind the scenes of the AI you use every single day. It's how Spotify just knows what song to play next, how Netflix recommends that perfect movie, and how those advanced AI chatbots can actually understand the nuance in your questions. This is fundamentally reshaping how we find and interact with information.
And that leaves us with a pretty cool thought to end on. For decades, we had to ask computers questions using their language, keywords. But now, as they're starting to understand our language, context, meaning, vibes, the barrier isn't the machine anymore. The only barrier is our own imagination. So what incredible, abstract, and deeply human questions are we going to ask them next? Thanks so much for diving into this with me.